Hello everyone, this is going to be a completely new thing on this channel, so I'll tell you about the idea first. So I wanted to make a larger project, something that you could follow along and watch me solve everyday problems in implementing such a project. This will be built with the type level stack using a lot of the functional stuff that I've been showing around on the channel in other content that I've been posting in my talks. So I just wanted to have something more complete, something like a full-blown project where we will actually go through the phase of implementing every layer uh, of the code of the architecture. And yeah, this will be it. So this is going to be quite a long series. I predict this will be about, well, at least 10, 20 episodes, and each one of them will be about an hour, maybe an hour and a half long. And I will not really edit, the silence out and so on, because it's just too much video to edit to go through. So this will be kind of like a stream, but recorded offline. Maybe if you think it's going to be fun, I'll do it live a couple times. I guess we'll see. So yeah, I think we can start. So the project I wanted to make, I briefly mentioned this idea on Twitter the other day. It's going to be a Docker clone. But it's not going to be like a full-blown Docker clone in the sense that it's going to deal with like file system images, something like that. We're not gonna have virtual, well, we're not gonna do containers. We're not gonna do anything like that. It's actually going to be, well, stealing just a couple ideas from Docker, like having a CLI that connects to a daemon running somewhere. But it'll be mostly like a compiler with caching. I guess we'll get to that later when I'm actually implementing this kind of logic. But yeah, actually I'll show you a demo once we have set up the project. So this will be like a complete walkthrough with like all the, like there will be no behind the scenes work. I'll show literally everything that I do to get this project to happen. And I realize there's music in the background. It's supposed to be free, so I hope I don't get a copyright strike. So we'll create a project with SBT. I have made some decisions already, like technical decisions on what to use in this. For now, we'll use SBT. Maybe in the future, we'll use something else. So yeah, here's my empty window in VS Code. Also, I'm not entirely sure about whether I want this to be watchable on like mobile phones, tablets, whatever. It would be better for me if I could, make the font smaller and just work as I would in a normal project. But if enough of you are going to watch this series on devices like that, then I'm going to keep using something that makes it readable on smaller screens. Otherwise, I would just use something that can be watched on a desktop. So the project name is going to be Stevedore. Stevedore, it's apparently a synonym for Docker. So I decided to use it. There's proof that there's nothing in the project yet. So there are several ways to start an SBT project. I'm going to do everything by hand just because it's going to be a custom crafted project. So let's open VS Code in it. Okay, that's my VS Code setup. First, I'm going to show you like the general idea. So when you have a Docker file, the font size, yeah. Hopefully this is large enough. So every Docker file starts with like a from, and you have a base image. So let's say you have Alpine. Optionally, you can specify the version. Like this is a tag, or you can probably put a hash of the image that you want to start from. Then you can put like a couple of commands like run, I don't know, echo foo into a file like build result, and then you can copy files from the current directory or a different image. I'm not going to do that. I'm just going to do this. And then you can specify like the command that will run when you actually start a container. So like maybe sh. Let's see. Yeah, let's show this file that we printed. And when you build this with Docker, I'm just going to show this to have a fair comparison of what we're gonna do, like how many ideas we're gonna take from this. So when you build this as an image, okay, this failed because we don't have a directory. That's fine. We're gonna create the directory. Okay, so the image was built. We can optionally like tag the image when building. This is going to be important later, but let's do like demo 001. And it doesn't really rerun anything. All the commands here are cached, which should give you a hint of what I'm going to try and accomplish in this whole project. And we can refer to this image either by this hash, this SHA-256 hash, or by the tag. Well, the tag is this. So now I can run it. I'm going to use the RM flag so that it removes the container when it's done. And this didn't work because I'm not good at this. Why didn't it work? Let me just try this. Well, bin state should be available. Let me try with more white space here. I don't think it should matter, but not this. Okay, I think we can just do cat like this. Maybe it will work. I don't deal with Docker that much to make my own images that often, so yeah, it doesn't see that file, which is strange. Build result. Oh, I see. This is cat. It needs to be a separate argument to this. Well, I need to build the image again. Okay, so now it works. So basically the idea of an image like this is that you start with some base. I don't really know how these are created, like how the empty image can be defined, but that's just a detail that we don't need to concern ourselves with here. And then you can do a couple of commands. Maybe we can copy, like let's have a, it was supposed to be a file. Like we can additionally do like copy res, and maybe we can print both of these files. So still the first run command was cached, and it should reuse the layer. Every command creates a separate layer, which I'm not entirely sure how they are built, but supposedly when you have a run, it will basically diff the file system and like store the changes. Don't quote me on that. I'm not a Docker internals expert, but the most important thing is that when I build this again, everything that I haven't changed, like before a change, like if I change this, the previous things, the previous layers are going to be cached, and we're going to reuse them. They will be cached in my like local Docker registry, and each of them has like a hash. So the registry will store these hashes and map them to these layers, and then you only have to rerun like the changed commands, or the commands that show up after something you've changed. So I think this should still be the same. So the idea is that we're going to steal from this. We're gonna have like a similar like file format. At first, we're gonna use something very easily machine readable like JSON. Later on, we might actually get a custom file format like this one, similar to a Docker file. We will not have a from, I think. Maybe we will later, but we will mostly have like run. And so the file that I was thinking about is going to be like pseudocode. We're gonna have like from, okay, maybe like a hash here. This might be optional, or from starting with like empty or default. And then we'll have like a key value store. So we'll be able to do like put key name value. This will be stringly typed, just strings and strings in the values. And we'll be able to delete key name. And there will be no command at first. I think we don't need that. Essentially what we need is just like a sequence of commands. And then at the end we will do, when we actually execute something that was built with this, we will just show the whole, like all the keys that are known. This will be like an upsert, actually you can call it that way. So yeah, just two kinds of commands at first. So we'll actually have a file at some point, maybe a JSON file in the beginning, and later something custom, as I said. And we're gonna have a command that will allow us to build an image from this. So essentially it will be like a compiler, but all of this will run at build time, at compile time, you could say. So we'll have one command that will take this and make an image out of this, and we'll be able to also run them, which will just print the result. And at some point we're gonna do, add a form of caching so that when you have a bunch of these, well, it thinks it's SQL now, which I guess makes sense. Like we're gonna try to do the same kind of caching mechanism as Docker uses, well, in a simplified way, because Docker has this problem that it has file dependencies we will not. Our only inputs are going to be the code after some normalization, because I want this to be the same as this. So like whitespace will be irrelevant and so on. We'll have to transform this into a data type and sort of calculate a hash of it, maybe a hash code. I'm not sure if hash code is going to be problematic here, like a JVM hash code, or we're gonna just use, something better. I guess we'll see. It'll also depend on the kind of storage system that we'll use for this registry of layers. But at first we'll do everything in memory with no external integrations whatsoever. At first, actually, we're not gonna even like expose any interfaces like HTTP or TCP or whatever. We're not gonna have that. We're just gonna deal with the business logic, so-called business, because there is no business. We're gonna deal with that first. Do some testing, do some, focus on the code quality and the design of that. And eventually we're gonna add layers on top. I think we'll have first like an HTTP server. I also think Docker works like that. It's an HTTP server, but it doesn't expose like a TCP socket, but a Unix socket. Forgive me if if a Unix socket is a subtype. I'm not an expert on that level either. I try to do Scala. That's most of what I do. So I think Docker does that. So we're first gonna do like a real, usual HTTP server on localhost, and that's gonna be our daemon of Stevedore. And actually, you know what? Let's just call it Steve. I'm gonna rename it. We're gonna have that, and we'll have a CLI at some point in the future. Let me just close this and reopen when I have renamed this. This is going to be just Steve. Much better. So Steve is a clone of Docker. Perfect. Yeah, so we're gonna have a server for sure. At first HTTP. Later on, we might use a Unix socket. I hope they work on Mac. I think they do, because I guess that's how Docker works here as well. Actually, now I'm gonna close Docker because I no longer need it, and it might be taking too many resources on my machine. Okay, so I'm gonna remove all of that. We don't really need the files to be there. Increase the font. And yeah, so I'm just gonna start this SBT project. We're gonna do everything from scratch, including like the Git setup, the Git ignore. I might actually create the repository on like while this happens. I guess I will. So I'll start with a build SBT file, and this should trigger Metals to try to, yeah, Metals is going to start. So Metals, again, if you're not aware, it's a language server for Scala. It works with VS Code and several other tools, editors. We're definitely gonna need a project build properties file. This will set the version of SBT. I'm going to use 155, and I'm not going to import the build yet because I want to set up some basics. If you're just starting with Scala, I do not recommend that you use this setup. You probably just should use IntelliJ. It will just help you in so many things. So I'm gonna start. We're gonna have a root project. This is how you usually create it in the root directory. We'll have some settings later on. Okay, we need a Scala FMT configuration. So it was created now. I know the latest version is probably 304. And yes, we're gonna use Scala 3 at least, as long as it's viable. I'm actually gonna use like the cutting edge version 310 RC2, because supposedly Metals works with it, and otherwise we would have a lot of problems with completions. Okay, so we have Scala FMT. Okay, so I decided to steal the config from another project that I had. This is going to be version 304 of Scala FMT, and we're gonna set runner dialect to Scala 3. I think that's how you're supposed to do it. It might complain later. So let's see. Okay, I think it did work, like the formatting works. So we're gonna just stick to that. So we have SBT, we have root. So I know for a fact that we will have a server and a client, or CLI. So I'm gonna create projects for that as well. Eventually we're gonna have like a shared module between them. I want to reuse the sources so that the formats that we defined, like JSON codecs or whatever, or the case classes for communication, we will be able to reuse them between projects. So I just defined this empty settings because I know I will be changing that very soon. And I'm going to do aggregate on both of these projects. Thank you, GitHub Copilot, for completing that for me. And now we can import the build. So I think it worked. In the meantime, I tried to close some background tasks because the performance isn't really the best when I'm recording. I'm still trying to fix that. Okay, actually I just switched to an older version of OBS, which I think worked better. Hopefully that's gonna work like that. So I'm gonna create common settings. That's a very common pattern in SBT projects you see around the world. Well, I have had this at probably every project at work and most of my open source projects as well. So I think you'll see this quite often. We're gonna set the Scala version here. For now, it's going to be the same everywhere. So 3.10 RC2. Let's hope this works. And also I'm going to open SBT again. Well, I'm going to open it by hand just to see, like validate my changes more quickly. Because with metals you have to open the project every time that you want to that you make changes. Metals will like start the SBT program, so this will start a fresh JVM, and then update the project and actually get some like generate the blue files, for example. And the process that takes by far the longest in here is like reloading the project, and then there's the overhead of starting a new JVM. So I'm going to avoid that by just using the update command to make it go faster. Sorry, that's not update. That's not what it's doing. Reload is the one. So this is going to run faster than the first time. So if you're making a lot of changes and you don't really need them to be available in metals immediately, you can use that. Or you can change your metals setup so that it uses the SBT client command instead. But then you have to reload yourself when you make actual changes, which is kind of a pain. So what I'm gonna do here, so we have the Scala version. Let's actually prove that it works. We're gonna work on the server first. I don't know why it created a Scala to 12 directory. So let's try. So to prove this is Scala 3, let's define the command. I will delete this immediately. We'll have a get and delete. Well, that was supposed to be put. Let's have this. Apparently it doesn't work. Source main Scala. Yeah, that doesn't... Oh, I guess I didn't use the command settings, so yeah. And here's a piece of trivia. Like normally, settings accepts a variable amount of parameters which are supposed to be settings, like whatever this returns. A setting, yeah. And you would have to use this kind of syntax, but it also has an overload that works with sequences. Or there's an implicit conversion to one of these, like this. I'm not sure if we can see it. We can. Okay, so yeah, so there's an implicit conversion. That's quite nice. So we set that. I think we also. I'm not sure if we should be doing this for root. Probably will not have any kind of sources in the root project. I don't think there should be. So I'm going to say publish this. I think that's how you're supposed to do it. Eventually, this would have been a pain, like if I didn't set publishing, disable publishing in this project. So this will check if we actually have the Scala version. Apparently we do. Let's try to compile. In SBT, so metals will still not work because we didn't refresh after adding these common settings to the projects. But SBT did when I did reload. So this reminds me that Scala 3 actually takes quite a while to compile, and I'm not entirely convinced that we should be using it. Maybe we'll be using Scala 3 to define just the data types, because enums are so much nicer in Scala 3. I guess we'll see. So I'm going to add some plugins to the project in my project/plugins SBT. I'm definitely gonna use SBT to Polcat. So let me actually look up the version because I don't remember. Okay, so this is how you add it, but I'm not sure if it will work with this RC of Scala 3.1. Okay, apparently it does work. We're also gonna get fatal warnings, I think, which I don't think will be a problem, but I'm still going to remove it. So I don't really like fatal warnings. I have explained why in a different video, which is not out yet by the time I'm recording this. But basically, I think when all your warnings are compiler errors, you get too much of a slowdown when you try to fix them one by one, or fix actual errors. You get like too much noise, and you are not able to see clearly which issues are actual problems at the moment. So I try to avoid that. So I think we are all set for now. We just don't have any libraries. And I know for a fact that we will need some. So I'm going to put some shared libraries into my common settings. We're definitely gonna use Cast Effect. I already mentioned that. I will not add like HTTP first or anything else like that yet. We will do it later. I actually think we might even abstract from communication so that we would be able to set it like in configuration whether we should have an HTTP server or like a Unix socket. I guess we'll see. Oh, and also I forgot to mention this earlier. When we do like a Unix socket or HTTP, TCP server, at some point we might even move away from the HTTP model because I think that's what Docker still uses. But I want to, use this as an opportunity to like, optimize and, for example, just create our own binary codec using Scodec, something more efficient or something, I don't know, maybe not Scodec, but like Avro or something like that. But for starters, we'll just do JSON over HTTP, and that should be good enough. And it's still going to be super fast. Like I think even LSP servers send like thousands of messages a minute with, well, I think it's JSON RPC. It's still, JSON. So we're gonna get the whole of Cast Effect, and I think the latest version is 3.2.9. That makes sense. We're gonna use that. Also, we're definitely gonna use some config, but maybe not yet. So I'm just gonna stick to cats for now. I'm wondering if I need anything else here. We might need cats MTL, so I'll just add it, but it will be commented out. I'm not even sure if this is the right artifact. It might be core, whatever. So I'll just put it here. And let's update the build again in SBT. And actually, I'm gonna check if this is the right artifact of customtl. It is, okay. So I'll still disable it for now, just to have fewer things to worry about. And let's import the build into metals again. In the meantime, yeah, let's just wait for this. We're not gonna use SBT that much. Well, it's gonna be used every time we generate stuff for Bloop for metals, but most of the time I'm just going to use Bloop. So this is server. It still doesn't compile because it hasn't imported, so let's look at that. Some errors in here. I don't think that's a problem. Like, there will always be some kind of exceptions in these logs. It just takes some time to notice which ones are fine and which ones are not. Also, I guess I forgot we need the testing framework. So I've got MUnit. That's recently been the one that I like most. So MUnit, cats effect, that's what I think we need. The cats effect 3 variant. Let's add that as well. It's taking some time to generate. So this is the speed that I get when I use SBT while recording. Normally it's faster, I have to be honest here. It's not that slow. I remember the times when SBT was like super slow to resolve any kind of dependencies back in the day when Corsair wasn't a thing. I don't miss these days. When I was starting my Scala adventure in like 2016, 2015, and using SBT as my first commercial project, that was a pain. That was very slow. The compiler was also quite slow back then. That was even before 2.12. So we've gone quite a long way since then. Like 2.13.6 is very fast to compile. Scala 3, I've seen it work better before the stable versions sometimes. I also heard that you can configure like how long it takes to, how long it can give your code, well, how long it's supposed to search for like missing imports. You can configure that, but I changed it to like 0 one time, or like to 1 millisecond, and it didn't really help at all. So I'm running the import again. Wait, that's the second time, so that we get the testing framework, but this already compiles, or Scala 3 code already compiles as Scala 3, which is nice because that's what we wanted. So we're not gonna have a main file, actually. I'm just gonna rename this to something else. I think we can actually start from the model. So let's see if I can, yeah, the tests will come later. So I'm going to define the model first. Maybe that's not how you should be doing stuff. Like maybe we should be doing the design of the architecture first. But I want to have the model, you know, not set in stone, but I want it to be ready before we start doing that. So yeah, so we're gonna have like a build. I think that's what we're gonna call it. And this is actually going to be a case class. And also, like, I have a feature set in mind that I want to implement as part of this series. But when we're close to the end and we are satisfied with the current result, I think it's fair to assume that we can extend the functionality to any kind of, you know, feature set that we want. So this can go on forever for all I care. If you like this, by the way, if you're still watching this, I appreciate this, and let me know like how long you've made it. If you watch the whole thing, I am gonna be really happy if people are gonna watch that. And also, I mentioned that I'm not gonna do like any behind the scenes work, but this project is going to be open source. It's going to be on my GitHub. I'm going to have a link in the description. I cannot put links on videos, like to arbitrary links yet, so you won't see a card here. Although when like if you folks are going to watch this, I'll get enough view time to become a partner, then I guess I'll be able to post links. Anyway, there's gonna be a link in the description for the project. If you, I think I'll have a couple issues always open, so that you can actually contribute to this and help me. And I will review all the PRs in the beginning of every next video if there are any, and you know, make sure that nobody misses anything if they don't watch the PRs themselves. We'll go through all of that in the beginning. Although I don't expect a lot of that to happen. I don't have that many followers or subscribers. But if you want to, be part of this and have your name in these videos and actually help me, I'd really appreciate that. I'm just gonna leave some tickets open later on. Oh, and we're gonna set up Scala Steward in the meantime as well. I might actually do it on the video. Set up Scala Steward, which is a tool that will make pull requests, updating our dependencies. But I'll make sure that we review these. Well, we at least look at these changes, these updates, maybe like review the change logs of the libraries every time we start a new video. For now, I just use the latest cut effect, and that's all we have. And MUnit cut effect, and SBT to ball cut, which doesn't really change much in the releases, but I guess it's all right. I don't think I have any flags that I like to use besides that. I guess source future might be one. Let's actually add it. So this was xsource 3.1, maybe. Although I guess we don't need it if we are already on 3.1. I wonder what imports look like here. If I can do import Scala collection, maybe this map, or all like that. So this works, but the underscore shouldn't, but it still works. Okay, I'm not gonna complain about that. So we're gonna have a build. I'm wondering if we should have a name here. Probably not. So this is just gonna be like commands, a list of commands, and a base. Let's have a base. And the base, of course, this is gonna be just a string, but I'm wondering if this should be, let's have an enum for this for now. Just a placeholder. That's what to do. I'm wondering what the base should be, because it can be either a tag, like, we had Alpine in the Docker files. Here we would have something like default or empty or hash. So I think we could be treating default and empty as a keyword, kind of. So then base would be like an option of base, of a string, of a hash. Or we could make it an enum, so that it's either default or something named. I think let's do that. This is gonna be fun. So build base, all build base. So object build, we're gonna have enum base. Also about Scala 3 syntax, like the braces. I'm gonna stick to braces just because I think that's the popular choice. We could be using the whitespace-based syntax, and then in case we have to run back to 13, which I think might happen, we would just reformat the code. I think Scala is able to change whitespace-based syntax, like indentation-based syntax, into braces. I don't really want to do that though, so because that would be a large diff as well. We'll have enough changes as it is with like enums. But I hope that won't happen. So if I ever get frustrated with how slow Scala 3 is, or like other issues with it, we'll go back to 2.13. I hope not. Oh, and also the client, this is just random information about the future of the project. The client is going to be compiled to a native image. I'm going to try that at least. It'll depend on what kind of dependencies we use, I guess. I hope it will be seamless or quite easy. I'll do some research in the background so that we don't waste time here, but all the work will be done on these videos. The point is to have instant startup, like the Docker command. It shouldn't start a JVM every time we run it. That would be just way too slow for a client like this. And eventually we might have a front end, I think when we expose the interface through HTTP at first, we will use Tapir, and we'll also get Swagger, so that we can actually call the API from the web, from a UI without writing one. So the base of an image will be either empty or, well, it's empty, or a hash, and this will be a SHA. This kind of hashing will be, actually, you know what? This is going to be hash. So that's going to be a different type. So like steve.hash. For now, this is just going to be value string. The implementation, like the detail of how we hash stuff to a string, or maybe like an array of bytes, that would be more generic. Like the detail of how we hash, I think that we can leave that for later. So I don't want to hard code it here, and I guess this just makes sense. So, because we'll have to choose a library for hashing and so on. Maybe it'll already have a type for it. We probably don't want an external type in here though. It's good that I don't have any dependencies here yet in the model, because the model can then be a Scala 3 module, and everything else can be a Scala 213 module and still use this. But if we had any kind of dependencies, we'd have to use the Scala 213 dependencies, and any kind of, like if we had any kind of macros in here, that just wouldn't work in the whole project at all. So yeah, I'm glad we don't have dependencies yet here. So we'll have either an empty image or an image hash. Maybe let's go like that. And then I don't need to do a fully qualified name here. And now the commands. So I mentioned I want to have put and like upsert key value, and I want to have delete of a key. And I think that's all. Maybe just we will be printing like the command that we are executing and the result of it, like what the final state of this key is, or maybe what we are transitioning from. We will be doing this during the build, so that it will be clearer that we are actually doing some caching when we actually do caching, and maybe we'll introduce some like artificial delays to show how fast the cached builds will be. That sounds like fun. So we have the command and everything. I think I can actually introduce the model or the shared subproject. So I'm going to do that. This is going to be shared project settings, something like this, and will depend on it here. I'm still wondering where to put the like the codecs when you actually have them. I guess that's going to be a problem, because if I want to have this, so what I just said about having a Scala 3 module and dependencies from Scala 213, that's probably not going to work if we are going to use any kind of macros, or if we're going to use codec, because codec between versions, that's not going to work. I think it's not going to work. It's going to be very difficult to deal with it if we try to do this kind of cross version. So the moment we get into problems with Scala 3, we'll just migrate everything to Scala 213, I think. And let's also put it here. So this aggregate here assures that when I run tests for the whole project, it will also run tests of all these projects as well. And the same goes for compilation and so on. But I mostly care about testing. Also, we'll need to set up CI at some point. Maybe even now. I guess we can do it now. That's going to be fun. I still haven't set up the repo. So let's get a repository, and I'm going to create an empty commit. So there it is. And I'm going to move this to the shared project when it's created. Although I guess I can just rename this to shared, and that'll make sense. So now this is the shared sources, and we'll have to create SBT will create the directory for the server code. That's a lot of stuff. Okay, I don't want to check all that in. So we'll have a git ignore. I usually make these myself, but you can use, there's plenty of tools that generate this for you, like extensions for VS Code or whatever your IDE is. And you can, I think, download these from like GitHub or some websites. By the way, I can see that we have a very low frame rate here. I'm recording this like everything together using OBS, my screen and my face, because it would be just too inefficient to record the video from the camera and then convert it to a common like a frame rate and merge that. It would be just too much time to render. I mean, it's doable, it's absolutely feasible. It just takes a lot of time, and I don't want to do that for videos that are going to be this long. So I think we have almost an hour of content. So when I see an hour on the current recording, I think that's when we'll wrap up, so about half an hour left. Yeah, so we definitely want to skip all the targets. I always do this. It might not work for your purpose. So I'm not sure why this... about that. Okay, that's better. So this is what we have in the project. And for now that looks fine. I also do ds stored, I think that's what it's called. So Mac creates this kind of, I think it's Mac. This kind of files are created, I guess for thumbnails or something. I'm not entirely sure. So this is all we want to check in the first commit. And the shared sources are, oh, I don't want to call it that. Let's call it model. Okay. And I think that's it. So I'm just gonna create this repository. Okay, supposedly it's been created. Let's just make sure it's pushed as well. And it is. So we have the repository set up. I said we're gonna do CI. I think it's the right time to do it. Because why not? Like as early as you can. So we're gonna use, let me try this first. SBT GitHub Actions. At first we're gonna use that, maybe at some point we'll use something else. Okay, so I guess this plugin, the Scala extension, doesn't work with SBT plugins yet. So here's a hint for Olivier, who probably isn't watching this, but I will send it to him. Let's hope if I remember this. Let's see if I remember it. So this is going to be code commit. This is Linus Buwak's organization, and I think it's 0110. Now it's time to check. Oh, it's 013.0. Fine. I was close. So I'm gonna work with SBT again directly. Just because we're gonna have to change the file a couple times, I think. So first of all, the Scala version needs to be global and it needs to be the same for every subproject, I think. So just build Scala version. That actually might be it for the setup, like for the basic setup. We definitely don't want to publish yet because we cannot. I haven't yet thought about distribution of this. I'm not gonna spend too much time on it though, because I know nobody will use this. This is gonna be used as just a technological demo, kind of like a demo of the libraries that we're using and techniques that we're gonna be using. So I think we're gonna just set up publish local, and we're gonna use Coursier to create bootstraps for us. The same way that I've been doing with Spotify Next, which is another one of my projects. I only distributed, well, I do publish to Maven Central, but I can very well just publish locally and then use Coursier bootstrap from the local repository, and it will create a file that is runnable and runs the program. Yeah, there's a bunch of unused Scala C options. Whoa. So kind projector is apparently built in by default. That's cool. And explain types as well. Or that might actually not be implemented in Scala 3 yet. I'm not sure. So this is what the compiler plugin called Splain used to do, now built into Scala 2.13. I'm not sure which version introduces it, but I think it's released already. And Scala 3 either does it on its own, like it already does, like explain types, or explain, or maybe it just doesn't have this yet. But I think it does some explanations like that. So we have published, and then I can, I can create a bootstrap, but I don't have a runnable class yet, like a main class at all in my project. So it's not gonna work. Okay, so we're going to do CI again. I've been distracted. We need to run GitHub workflow generate, and let's see what that did. So we got a new directory called GitHub workflows, and we have 2 jobs. That's the standard. So I just want to make sure that we have everything we need. So we have some sort of Java. I would like to use Java 11, but I don't remember what the exact name is for it. But I think it's fine if we just use 1.8 for now. I think it should be working fine. So, oh wait, it does publishing? It does publishing always? I wonder what that would look like. Let's see. Okay. It doesn't work because we don't have a version scheme. Oh god. I'm gonna do early December, I guess. Although I don't think we're gonna... I'm not entirely sure we're gonna do like any kind of versions. So I'll definitely create like a tag 001 at this point maybe. And now let's run SBT again. The tag is necessary. Oh god, I'm not even sure if we have a version yet. We probably don't because we don't have a Git integration. So I'm gonna also add another SBT plugin, SBT CI release by Olaf. But I'm only gonna add it for these plugins. We're not gonna publish the Sonatype or anything yet. Maybe we will at some point, but for now I just want this. I want the version to be set because for now version, yeah, it's like a default version, and it should be 0.0.1 plus something snapshot, whatever. So when this reloads, I'm gonna see what the version is. So I know this is a little boring because there's a lot of wait. I'm going to try to skip some of the longer silences from the video, but there's still gonna be a lot of boring stuff like setting up SBT. If you're not into that, I think we won't be doing a lot of that in the future videos. This is probably gonna be the most that you see of it, but yeah, I guess we'll see. There's still some work to be done in the build in the future, like adding new dependencies and so on. Hopefully that's gonna be faster, and maybe we'll migrate to another tool at some point, which will make this easier as well. Although with these modules, I'm not entirely sure. Yeah, I wish I could tell you what I'm talking about, but I cannot, not yet. I'm also gonna add skip and publish. True. I also wonder if skip has like a special meaning in all of tasks. No, only some tasks support it. So I think we need both of these things to actually skip publishing in that project, and we need to use different kind of syntax. Like this. I don't know if we need the parentheses. I've been learning how to pronounce that because I've done it wrong in the past. It's parentheses. Well, yeah, okay, I think I did it right. So I'm gonna try to publish again. And I don't really know what it's gonna do, whether it's gonna try to publish the Sonatype or what. Hopefully not. Because if it does, I'm gonna have to set up credentials in the project, and that's asking for trouble, kind of. I don't want to do it yet. It's taking a while. It's taking its sweet old time. And there are no sources in here to publish, so why? Server directed to main time. So it's definitely talking to Sonatype. That's not good. So I'm gonna disable the publishing in the whole project for now. And we'll go back to Daniel's project. I want to skip the publish part. Okay, this goes to an empty seek. So this should ensure we don't run the publish job. I'll set the leave the version scheme anyway, and make sure that publish local works. Although we're not gonna use it in CI either. So now we do GitHub workflow generate. Also, I wanna try something. If I connect to this using an SBT client, and now I stop the server, does it actually? Yeah, it turns off everything. That's not cool. So I think I want to use a server here because I've been doing some changes to SBT all the time, and then every time I have to exit. So when I exit SBTN or SBT client, when you start SBT like this without the server running, now if I go out of this, after it's imported, well, loaded the build, when I just disconnect and I connect again, it's almost instantaneous. So now I need to reload, which is going to be much faster than the first time. First time it took about 28 seconds to just start it and disconnect. And now we did it in half the time with some waiting, so it's much faster. So what I was saying, we got this. I don't think we need to import into metals again. We didn't change anything related. I'm just gonna add this and hope that it runs in GitHub. So this is the repository. It's not documented at all yet. I'm gonna add some stuff in here, so by the time you're watching this video, there might be content in here, like a description or whatever, or some tickets to implement. Probably not this time. I think we'll have tickets to work on after the next video, because in this one, I don't think we're gonna get a lot of code for you to work on. And it's dark again. Nobody told me this, so I need to change some settings again. That should be fine for now. It's getting darker, and my setup for like lighting is not very good. I should also get a better microphone, I think. One that's, I guess this one was made more for like podcasts and so on, when you don't have to like show your face. You can actually hide your whole face behind the microphone and be very close to it. I cannot do that because I need to put my head on something. Back to the work. Yeah, this is a lot of distractions. Okay, so we have the model. I'm wondering what we should do next. Probably define some interfaces, right? So this will be in the server. I just had an idea that we could support like two modes of building stuff, like client side or server side, and have the same kind of algebra. Or, have the same kind of code and the same kind of interface, so that the client will not even know whether it's being done locally or remote. But we can always do that later. I'm just gonna do it in the server for now. So one implementation will be like, based on whatever the server does, like whether it's in memory or talking to a database with all these hashes of images. And one of the implementations will be the client side, which will use HTTP or TCP or whatever to talk to the server. But yeah, there's always time later for that. So we're gonna have, well, I guess it's time to define the commands actually. Like not the commands for the build, because these are build commands. So I think I'll actually move this here into the build. So this will be a build.command. And we'll also have commands like in general, so that what you can do with this client. And this will be either build, so like docker build, and this will take an optional tag. We'll also have run with a required tag, or like, we should have something like tag like, you know, so that you can use a tag or a hash. And we'll use it here as well. So maybe tag like. Tag will be a tag makes sense. Also, like in Docker, you have these namespaces, right? So we have like kubectl / Steve colon tag, or you can just have like kubectl / Steve. And here we have just the empty image. So image hash, maybe let's call this a reference. We'll have, actually, you know what? I think let's make the hash required for now. So the tags, yeah, let's actually skip the tags. We will not have any tags at all in the initial phase. It's just too much complexity for now. We can always utilize tags later as a kind of alias for this. So let's pretend we don't even know we're gonna use that. So we'll have either an empty image or in reference, that's fine. And we'll have to build. This will output a hash, and we'll run a hash. I think that makes sense. So we'll just pretend like we are not planning to add tags later. The refactoring will be a little more difficult because of this, I'm aware, but I have to have, you know, some content to make. So this will take me some more time on the recording. No, not really, but yeah, I think it's best if we do that. We can think about how we want to do namespaces and so on later. Maybe we will extend what Docker allows you to do. At least I think it doesn't allow you to do things like, you know, nesting namespaces in other namespaces. For example, you would have, I don't know, you would have a kubectl organization and then a Steve namespace, and inside that you would have images like model, client, server, whatever. Like, you know, I'm thinking like more than 2 levels, so you would have more nesting allowed. We can always do that later, and that's gonna be an interesting thing, especially when we try to build like a front end and a way to view all these images under an organization. That would be sick. But yeah, it's gonna be very complex. Let's just stick to the simple thing, just working with hashes. So this is a command. This is what we can run as a client. At some point, I'm gonna move this later to a different file later, but we're gonna have like a command eval commands command engine. Let's call it Executor. Very, very generic name. We can always rename it. And it'll take a command and return f of output. So now the question we need to ask when we have this kind of algebra is whether we want the output to be, you know, type safe. When you run a command like build, do you want a build result? And that's probably the case. You probably want this kind of specific type. So we probably don't want this kind of type. We will have a separate one for every case. And I'm not even sure what we gain by having a command like this. Yeah, I guess let's do it separately. So we'll have a build. This will take a build actually. So this, and I actually think like this is a CLI kind of command, but this needs to refer to an image somehow. So in the CLI we would build like a directory, but this is not going to be CLI related. This needs to be generic and needs to contain all the information that you need to build something. So we'll have the whole build description here. So build steve.build. This will refer to that, to this. So all the base and the commands all needs to be in the command here. So we'll have this, and this will result in probably like a stream of events. That's probably gonna be the final result. But for now, for starters, we'll just return the hash and the events will be just logged. But we want to be able to, have a stream of events, like what is being built and maybe what is being printed during the build. Like in Docker, you would have all these commands that are executed, and we would like to, in this case, see their outputs. I don't think Docker shows you that, but I want to show it here. Like the state transitions that we do in each command like this, right? I want to show that. So these, to show them on the client, we'll need some sort of event stream. But for now, just a hash, just the final result, and we'll log this in the server. I think that's reasonable. Yeah. Or we could do like the client, every time you run a client command, it will connect to the server and just subscribe to the events sort of in a background thread or fiber. But then we'll have to worry about synchronizing like which notifications to send to which client. And maintain like a separate connection. I think it's better to just build it into this later, into the single like executor command. Yeah, let's just call it that. I can always rename it later. So we'll be able to build and then we can run. And this will output, I think we can output like a stream in here. This is going to be easy enough that we could do a stream, but it's going to be more difficult to serialize. So I think we'll do like a similar thing. We'll just log on the backend immediately on the server or the daemon, but we will return, well, there's something we have to return or not. Yeah, let's just skip it, like return unit. I was thinking we should be doing like a stream of strings here, but then it also makes everything complex. So run doesn't take a run, it takes a hash. So a hash corresponds to like a program, right? And it's not really run because we will run this during the build. This will basically get the output. Maybe at some point we can do, change the file format for the command so that for the build, so that you can also do like a CMD, like the final command, like what gets run when you actually execute this image, right? Like in Docker, that's the run. That's the exec command, I think, or CMD. That's CMD. Yeah. I don't really remember if there was run or exec or what the difference was. Anyway, this would be like what gets called, the entry point, whatever. What gets called when you run this build image or this build program. So build will be like, yeah. But for now, and this would be essentially what would get printed here. And instead, what we'll do, this will just print the final state after that hash. And if that hash doesn't exist, we will fail. And as for the exceptions, like any kind of errors in here, error handling, I think every command will have its own error type, but it will be kind of implicit in this F effect. I don't want to do typed errors in here. Although at some point we maybe will do either, build error and hash, something like this maybe. Or not. I don't know. It might be just, hidden in the effect and we'll just catch it using like a recover with or something like that from cats. So that's basically the interface that we'll have. Let me add the boring stuff. I'm going to regret using this, like the using keyword, if we ever have to go back to Scala 13, but for now I don't care. This is gonna go to the server, so let's make some folders. And I guess that's it. Now, I want to use metals. Does it work? Oh, it works. That's neat. And I just now, yeah, I now just have to move it to the different module. By the way, I haven't focused so much in this during this video on my pronunciation. I hope you can actually understand everything I'm saying. I know it might not be that easy. So we have about 10 minutes left, I think, until we stop for today. I wanna define some more stuff still, but there's so much stuff we could be doing. I guess we can implement like a fake instance of it and just do something that only works for the empty file, so that, yeah, I'm actually gonna write a test, although I first need an instance, so we'll have an instance. I don't know what parameters it's gonna use, and it's gonna be an executor of f. Okay, does this work? Apparently it doesn't, like metals doesn't have completions for whole methods yet, but thankfully GitHub Copilot can do that. So yeah, I thought I had these off, by the way, like these super references. I thought I had them off. Doesn't really matter. So in the build, as I said, I'm gonna. I think that's the shortcut. Yeah, although I wanted this the other way around. Oh, you can barely see the code. I need to, yeah, I need to look at my recording screen so that I don't cover it in my face in this split screen. This should help. Hope the font is large enough. So we want to support the build of an empty image. Also, we need some sort of hash for the empty image. I was thinking, yeah, I guess for now we can just come up with some kind of random value or use a, an empty array or whatever. For now, I'll just use an empty array, but this will be an implementation detail here, and we will not rely on that anywhere else. Empty hash. And this is going to be a hash array empty. Sounds good to me. Yeah, eventually it might be, like let's say a SHA is 52 characters long. I'm not entirely sure, but that's the length in Nix of the Nix hashes. This wouldn't work because, yeah, it's just an empty array. Yeah, we probably will have like a fixed size array for the hashes, or maybe this will be a special case, I don't know. Actually, let me make a test for that first before we start implementing it. So source, hold on, tests Steve. Okay, I'm just checking if it fits on the screen. Let's make it larger. This is going to be a MUnit effect suite, I guess. I think that's how we're supposed to do it. So we have the executor. Of IO. For now it's IO, but I think I want at some point. Actually, you know what? Let's do ID. I want to. I don't want to have too many tests with actual effects. So I don't know if it's gonna work. Like, can we do an? Yeah, I think we can still do like a test without IO inside the class effect suite, and still it's gonna work. So build empty image. Okay, that's almost right. Let's open the executor. Let me just check my messages. Okay, nothing's burned yet. So when you take the executor and we build it, and we build, we build an empty build. So starting with build base empty image and no commands. I was wondering if we should make this like a non-empty list, because does it make sense to have an empty build? But for now, we'll allow an empty list. I guess that would be a way to create like an alias, but I don't think there's a point in this. Anyway, building an empty image should be almost instantaneous. Like the moment we notice that you are using an empty image, this should not incur any kind of network calls, assuming the empty image is like, you know, the server knows what it is. And no commands, so this should be like immediately returned even after we're done with this prototype. When we are actually in a real implementation, it should still be like this. Okay, so it's now dark outside, so I just turn on the lights and we can proceed with this. I think that's going to be the last thing we do today. So this should give us a hash, and I'm not going to recheck what the hash is. Build and run. So I'm going to test the interaction of these two commands. When you build something and you run it, you should have some sort of result that is based on whatever you build. I think that makes sense. And eventually maybe we'll have like an integration test so that when you build any build from the client, you should have the same result as if you just built it on the server. I'm not sure how useful it's gonna be, because it's essentially gonna be like just testing something that's already gonna be provided by a different library, like probably by Tapir, or if we don't use HTTP, it's gonna be, Codex. But I guess it will be an interesting test in the future. That's way ahead of us. So that's the hash, and we're gonna do exec run this hash. That doesn't have a result. Yeah, that's actually kind of bad. So maybe instead of unit, what would we expect to get? This is supposed to be like the state of the system, like the key value store. So maybe we can just get a map of all of that. I guess that would make sense. But it's going to be internal to the server. So I'll make this. By the way, are these classes final? Yeah, I'm not sure if they are final in Scala 3. Maybe at some point they are gonna be final by default. I hope they will be, because in Scala 2 that wasn't the case, so I always add it. Otherwise you can subclass a case class, which doesn't really make sense. It scares me. So we're gonna have the state of the system, but like key state. I'm kind of worried about this. I don't think we should be. I don't really know if this should be, public or part of the executor, or like an internal, type here. But then we wouldn't be able to do anything with it. So okay, here's an idea. This is gonna be a trait, and we're gonna have describe, or like get all. Yeah, something like this I think makes sense. And this will be our private implementation detail. Private final case class. Perfect. Wait, that's not allowed? What? Why? Too nested? Yeah, that is just way too. So, so this is not exactly the same as the case class. Let's just call it system state. We can always rename this later. I don't want to spend too much time on it. And that's gonna be the output of running a program. And so here, get all should be, well, that's the wrong framework. Assert equals. This is gonna be an empty map. That's always gonna be the state of the empty image. And actually I'm gonna special case this as a value in build. So when we go to build, we're gonna have it here. So when we build it empty, we want this kind of result. Let's start running these tests. They should be failing immediately. Over Okay, it's empty. I mean, it's failing. So let's implement it. So as I said, this is not gonna do a lot of stuff. We're only gonna return the hash for now. So we're definitely gonna need an applicative here. That's for sure. Oh, how imports work. I remember the times when you would have to, type everything in Scala 3, and even with metals during the RC phase of 3.0. I had to, I had some fun with that. It's much more fun right now. So then, when we run the hash, by the way, no, this cannot work like that. We need to ensure that build is the same as the empty build. Normally, this is where we would involve, like the cache mechanism and evaluate every layer. I assume there's gonna be like a fold in there, or a scan, something like that, or an unfold, or a traverse. Who knows? There's definitely gonna be a traverse somewhere in this application. I can guarantee you that. But for now, I'll just check for equality. Like, is it the same build that we know? And yeah, let's check. So if build is the same as build empty. If it is, we'll do empty. This is gonna be an option, so then we do lift to have. Let's just fail with a random throwable. Unsupported. I'll need a bunch of syntax for cats. It's gonna take me a lot of time to get used to this kind of syntax for imports. But, well, somebody has to do it. So this syntax, the guard syntax, is from the alternative type class. By the way, we're gonna do this. Or not. We don't have cats deriving yet, like a derivation library for Scala 3 and cats. So I'm just gonna work with that. What do you mean you don't have an applicative? You do. Of course you do. Oh, so that's a wrong error. This shows up because I think it shows like the first, well, the wrong implicit not found message. So when we go to monad, well, applicative error, you'll see it doesn't have an implicit not found annotation, but applicative does, and it says this. So Scala 2 would show you, I think, all of them. I'm not sure if this would be inherited in Scala 2. Anyway, the real problem is that we don't have this, and we need an applicative error for throwable. So this is called applicative throw in cats. It's just a type alias. This should compile and not work yet, because we haven't implemented run. Let's do so. So we're gonna do like the same kind of thing. So hash empty. Let's go with an empty hash. Oops. And this is going to be, well, actually, let's call this get all and make this extend system state just like that, as kv state map empty. That should do it, and the test should be passing. Except this doesn't work. This needs to be empty hash. Yeah, I definitely need to work on the performance of the stream because, well, this video, the frame rate on my face isn't really the best. Now we are missing some more stuff. Okay, there's no applicative throw for ID, so the tests don't compile at all. We're gonna do either. And I don't know what the right syntax is right now in Scala 3. Okay, it doesn't, what? That's not the right error. Okay, so I think that works. So this kind of syntax in kind projector. I think we're supposed to do like underscore, maybe? Eventually that's supposed to be supported. No. Or is it? Maybe it should be a question mark? I don't remember what the target is. Yeah, let's just use the star, the asterisk that works. So this is an either. We're gonna flat map. Well, let's do it for comprehension. Actually, no, we're gonna flat map. So this flat map exec run. We'll just put this in here. And then we're gonna map to this get all. And this is supposed to be right map empty. Okay, this is green. That's good. So we have our like basic test setup, and apparently it works. It runs, and we have our first like interface. We also made changes to the names in the base. Like a build base can now be an image reference, not just an image hash. We happen to use a hash for now, but in the future it might be like a tag as well. Oops. We defined the commands. Well, they were there already. That's just a weird diff. We moved the commands inside the build, which makes sense, I think. And we made some case classes final. We got the empty build value, and we have the test. So actually, let me check if the project, if the CI works already, because we didn't check that. Yeah, it's green. Apparently it works. I wonder how long it took. 1 minute. That's quite fast, even for Scala 3. I'm just gonna commit that because I trust everything will work. Well, we did run the test, so I think now that we have this, like we have the logic for the empty build, like I can see that it's clearly very far from the end result, but it returns something, and we could already build the client for it. I think that's not an unreasonable decision to start writing the client now. So defining like probably a protocol for communication. So I think in the next episode we will like pull in some kind of HTTP library so that we can communicate with these systems, the server and the client. We'll start writing the client logic so that we can maybe run a Scala class that will just send some command as a testing method. A method of testing in this sense. So we'll start doing work in the client using this shared model. And I think we'll also try to share this. There'll be a client implementation of Executor. So we'll have to split this and move this instance, the server instance, somewhere else. And we will probably not be defining the CLI yet. Like using, defining the main class that will actually parse the arguments or whatever, the commands. Although I can already tell you it's going to be, we're going to use the client library. It's probably the best one I know for this kind of stuff. And yeah, so we're gonna focus first on the logic inside the client, or at least the communication from the client, and reusing this interface. And yeah, because the client isn't gonna have a lot of logic. It's mostly gonna be just decoding the commands from the CLI parameters. At some point, we're gonna start reading files. So the files will have to be parsed, decoded into a command. Sorry, into a build, right? That's exactly what the file will be. So we will reuse this model probably. That'll be a file, so we'll have to decode that from maybe JSON or in the future a custom crafted format. Still has to be human readable. So if we made a custom one, we would have to define a parser. And eventually the client will also have to, well, the client will also have to just serialize this kind of stuff in some way and communicate with the server. I don't think we're gonna do like server discovery. Yeah, it's gonna be really simple. Well, the communication method, maybe the protocol will also be like defined in the share module so that we can switch it in one place. I don't think that's gonna work. Although if we did have like a, switch between, is it a Unix socket or is it a TCP connection? I think we can put that logic into the shared module. Anyway, that's it for today. So I'll add a README. That's gonna be the only thing that I do off screen. I'll add a README, put some information in the repository. Probably no tickets yet. There's nothing really to implement that I don't want to show live. Well, as I go through it. So yeah, there'll be README. I hope this is an interesting format and that somebody actually watches these till the end. If you do, I appreciate you very much. Let me know, leave a comment, do all the stuff, like the usual, like and subscribe. And yeah, let me know what you think about the format. Like, if you have any ideas for this project, how to build it, what you would like me to do so that you can learn how to do it. And yeah, whatever you would like to see in the future videos in this series. And maybe I should focus more on the architecture, like this, how I come up with this design. Or maybe I should focus more on just coding and leave the design decisions for the background so that I can think about this in the meantime. I wanted to show you the whole deal so that whenever I actually think about stuff, you can actually see what options I'm considering. So I hope you appreciate that and that actually helps you somehow. So yeah, I guess that's it. So thanks for watching again. And I think I'll publish these weekly, maybe bi-weekly. So expect another episode in at most 2 weeks. That's all I have for today. So thanks again for watching and I see you in the next episode.